Welcome back to The Glow Life. I'm your host, Maria Marlowe, and on today's episode, we'll be discussing how to reverse your biological age through diet and lifestyle with naturopathic physician, Dr. Kara Fitzgerald. Dr. Fitzgerald is trained in functional medicine and is even on the faculty at the Institute for Functional Medicine. She recently conducted some very interesting research on biological aging. And what she found is that specific dietary and lifestyle factors, which we'll discuss on today's episode, can actually reverse your biological age by impacting what's called DNA methylation. And if you have no idea what DNA methylation is, that's okay. We'll discuss it in this episode. But long story short, certain foods and certain habits can actually keep your cells younger, can actually prevent disease, can prevent mental decline or cognitive decline, can prevent even aging of the skin. So I think you'll find this episode really interesting. To be honest, it's all the things that you'd expect: eating a healthy whole food diet, getting enough sleep, all that good stuff, reducing your stress, even meditation. So we'll touch on all these topics, but I think you'll find it really interesting how they all play a part in reducing our biological age. And if you're thinking that it takes forever, it actually doesn't. You'll be really surprised at how quickly these changes can make an impact on your health. This episode is brought to you by the Clear Skin Plan, my 90-day program and meal plan to clear your skin from within naturally through dietary and lifestyle changes. Skin issues like acne are not only skin deep. They start deep within with internal inflammation and imbalances. The only way to clear your skin is to address those underlying root causes, and the Clear Skin Plan will help you do just that. With the plan, you'll discover the potential underlying root causes of your breakouts and how to remedy them through dietary and lifestyle changes. You'll also get over 100 delicious skin-clearing recipes which you can mix and match or follow the weekly sample meal plans with shopping lists. This program is science-backed, dermatologist-approved, and doctor-recommended. To get it, head to mariamarlowe.com/clear-skin-plan. Dr. Fitzgerald, thanks for coming on the show.
Absolutely. It's my pleasure to be here with you.
So you've done some really interesting research on biological aging and how we can actually reduce our biological age through diet and very simple dietary changes. So can you share a little bit about your research and what you found?
Yeah, absolutely. It's really pretty extraordinary. Not long ago, scientists did not think that we had much power around slowing down biological age, and especially with diet and lifestyle interventions. Maybe scientists are already looking for sort of the drug that will stop the aging journey. But, regular things that we can do on a daily basis, there was a lot of doubt around it. And in fact, ours was one of the very first studies, and it was the first controlled study. So we had a group that did the intervention and a group that didn't, and we compared outcome to show that, in fact, diet and lifestyle can go a long way towards reversing biological age. So unlike chronological age, we're getting older as we speak, every year another number. Biological age is whether we are aging faster or slower than our chronological age. And so the fact that we can turn this around is extraordinary. And I'm so sorry. What was your question? Okay. And you'll edit.
Yeah. Don't worry at all. I was choked on my own spit there. So what were some of the foods that you found to be most beneficial for reducing our chronological age? And then can you also just, so biological age, we understand that like it's the day, the time, the year, like we understand that
chronological.
Chronological, we can't change that.
Yep.
That's just happening. But the biological age, like what are some markers of age? Like how do we even know what our biological age is?
Yeah, absolutely. So great question. Or actually, there's two questions. There's one on foods and interventions we can do to slow it down and how we measure it. I'll talk about how we measure it, and then I'll talk about how we can slow it down. We measure, so the gold standard for measuring biological age is looking at gene expression. Specifically through the lens of epigenetics. So let me just define it. There's genetics. Everybody knows we've got DNA, our genes themselves. But where the rubber meets the road is whether those genes are expressed or not. And we can, and that's the study or the field of epigenetics. And we can look specifically now at, these millions of ways that our genes are turned on or not, called DNA methylation. And we can see from these various patterns which genes are on and which genes are off, or which genes are likely to be on and which genes are likely to be off. When we age, there's actually a pattern that is associated with increased inflammation, increased risk for cancer, increased risk for diabetes. There's kind of, a rather extraordinarily predictable pattern as we age towards the chronic diseases of aging. In fact, aging itself is the biggest risk factor for all of these chronic diseases of aging. And we can look at these patterns when we look at epigenetics, and specifically DNA methylation is where we put a lot of our attention. So we can measure biological age using these same, looking at DNA methylation and looking at patterns associated with accelerated or, let me just restate that. We can use DNA methylation to measure biological age. And so we can tell, for example, whether we're aging faster than our chronological age or whether we're actually aging slower by looking at these patterns. It's extraordinarily exciting and powerful. And these are tools that we'll be using more and more and more. I want to say, though, that there's other insight. There's other ways we can get insight into whether or not we're aging faster or slower. And these are a lot of the tools that we've used, forever, personally, or at home, or when we go to see our physician. So this is blood pressure, or this is weight, or this is marker of inflammation. Classically, we look at something called CRP. This is our white blood cell count. Is it very high or is it very low? So there's a handful of relatively standard markers. Our muscle mass, our bone strength, our ability, our balance, our cognition. So all of these things we tend to lose as we age. And so these are normal things that we can do, that we can think about at home or with our doctor. And we don't have to jump into yet necessarily measuring DNA methylation, although a time will come, and it'll probably come relatively soon, where we are looking at this more routinely.
And so right now, though, obviously we can kind of see, like, are we forgetting things more frequently, or
Yep.
is our blood pressure changing? Is
Yes.
our weight changing? Right. Obviously, we can kind of monitor those things. But in terms of DNA methylation, if someone did want to figure that out, is that something they can just go to their doctor with now and ask for a test, or is that something these DNA tests do? That are very popular now. Like, where would someone even go for that, or is that something that's just not available yet?
Well, it's interesting. It is available now. There's a handful of labs that are offering direct to consumer testing. Chances are pretty high that your physician, your primary care provider, isn't going to be using this testing unless you've got a really sophisticated primary care provider. Even in functional medicine, where I come from, we're not using these routinely yet, but we will be. So, for instance, if someone comes to our practice, certainly we offer them, and they can ask if they're working with a functional medicine provider, so they can check in with that provider, and that provider, even if they're not offering them, they can track them down. But there are some direct to consumer offerings, and I can tell you about those if you want me to.
Yeah. Sure.
Okay. So there's a lab called Zymo, Zymo, and they have a DNA test, a DNA methylation biological age test specifically. That's different than just getting your SNPs tested through a company like 23andMe. This is a very different test, both related to genetics, but they're different. So Zymo does it. A great lab that we're working with now called True Diagnostic offers this. And then there's another lab called TrueMe, just TRUME, that offers a direct-to-consumer, simple, kind of smaller test. So there are ways to get them now. They're gaining in popularity. Pretty soon they'll be right up there with the 23andMe testing. We have, as a part of our sort of the next phase in our research, we've released a digital program called 3YY. 3YY. So it's 3 years younger, which is the main finding in our study that I'll tell you about in a minute. So it's 3YY. And within this digital program, you can access biological age testing. You can access the nutrition team that we worked with, et cetera. You can access our study program, and you can participate in research or not. So it's kind of a one-stop shopping, if you will, the 3YY program for folks to access it.
Interesting. And so what were some of the dietary changes that you found to be most beneficial to reduce those 3 years?
Yeah, absolutely. So let me just sort of our amazing finding and kind of our first of its kind. It got a lot of attention because we were able to show in 8 weeks' time, our participants shaved off 3.24 years of their biological age and it's still the shortest time frame to show that degree of biological age reversal. The foods, so a lot of these we're well aware of, and we know that they're smart. We packed the diet full of kind of the classic methyl donor nutrients. So lots and lots of greens, good greens, not those microgreens that some of us really like, not iceberg or romaine, but nice dense green greens, if spinach and kale. We did a lot of cruciferous veggies, a lot of colorful, beautiful veggies, but ones that are low glycemic. So we don't want you diving into potatoes or even necessarily doing a ton of sweet potatoes, although those are okay. We want you to think about, different varieties of peppers and, different, just survey your fruit and vegetable selection. Hopefully you've got access to good ones at a grocery, and just buy far and wide. We had at least 7 cups of these good veggies per day. We also have beets in our study, not a ton of beets because, there is sugar in beets, but 2 medium-sized beets. And these have a compound in them called betaine. They actually have a host of compounds in them that are brilliant for methylation. So again, thinking about DNA methylation, but betaine is one of the main players in beets. So we want people to be getting 2 of them per day. Also, berries. Berries are, kind of miracle fruits as far as DNA methylation goes. So, if you can go for organic as much as possible, go for wild as you're able to access them. But, things like blueberries and blackberries, strawberries, just the nice, dark, good berries. Nuts and seeds are a big part of our program, especially sunflower seeds and pumpkin seeds. Again, dense with these methyl donor nutrients. Eggs, smart. If you're not allergic to eggs or you're not a vegan, eggs are full of a compound called choline that just helps. It's a key methyl donor, and it just plays a good, important role in DNA methylation and, again, biological age reversal. So go ahead. Mm-hmm.
So let's actually back up for a second. So you said, can you just explain a little bit more of the whole study design? Like, how many people did you have? And then, what exactly did they change? Were they just eating 7 cups of vegetables a day? Like, was that the only change, or like, what exactly were they doing to get these amazing results?
Yeah, so it was a lot more involved than 7 cups of veggies, some fruits and seeds a day. Our study population, it was a pilot study. So that means that the numbers are relatively low. It was an intense and expensive study, and we hired a clinic research center actually at my alma mater, National University of Natural Medicine out in Portland, Oregon. We hired their research institute to run our study. We looked specifically at middle-aged men. We had 18 in our study group and 20 in our control. These men were between the ages of 50 and 72. We wanted middle-aged men in the study for it, as opposed to middle-aged women or a mixed group, for a couple of reasons. We wanted to look at the middle age range because that's when DNA methylation really starts to go, wonky a little bit, where we start to see the changes associated with the chronic diseases of aging. We start to see the changes associated with aging. So we wanted to kind of get right in the heart of that age range, but we wanted healthy people. We didn't want people with diabetes or cardiovascular disease or, obesity or hypertension, et cetera. We wanted healthy men. The only reason we didn't include women, obviously, I am one. I want to study this diet in women, and I certainly have looked at it on a one-on-one basis in my practice and with myself, but we didn't in this group because women between the ages of 50 and 72 could be premenopausal, so they could have a regular cycle. They could be perimenopausal, where the shift is, right in the middle, or they could already be postmenopausal and have not menstruated for, many years. And that hormone shift is significant, and we need larger numbers to be able to see through those changes. And so for our first jump into the pond, if you will, it just behooved us to look at men. But we are actually in the 3YY app, again, I mentioned earlier, we have approval, institutional review board approval, which need to have to conduct research in humans to go ahead and continue this journey. And of course, women are in this study. So I just encourage anyone who's interested to check us out. So men 18 in our study group, they followed our diet. Yes, vegetables are the cornerstone of our diet, but we also had some animal protein. This is a diet that includes both, animal protein as well as, veggies and so forth. We do incidentally have a vegan program now, which we're studying, and I can speak more about later. But for this program, it did include animal protein. We want people, those adventurous folks, to consume liver if you're willing to, just a few times a week. Liver is the original multivitamin mineral. I mean, before we had B vitamins, before we synthesized vitamins, people were prescribed liver, and a lot of it. So if you were anemic, for example, you'd be prescribed liver. If you needed B vitamins, you'd be prescribed liver, et cetera. So we included that, clean source liver, adequate water. We pull out pro-inflammatory foods like dairy and simple carbohydrates. It's a grain-free. This 8-week program is grain-free. We also took out legumes. Primarily, we don't want people to stay off legumes forever. There's, fabulous. When you look at centenarians who are living today, so if you look at Blue Zone research, you see that many legumes are consumed in those populations and they do well and they're healthy. But just for this little 8-week chunk of time, we wanted to keep the glycemic index low. So we really wanted to minimize spikes in sugar and just keep blood sugar relatively low. And so we kept the diet in that direction, sort of lower carbohydrate, higher fat. We incorporated some modest intermittent fasting. We wanted the diet to be kind of keto leaning. So we asked people not to eat after 7 and not before 7. So just a 12-hour window. What else did we do? Again, adequate hydration. We lean on a class of nutrients we're calling methylation adaptogens. These are epigenetically bioactive nutrients that we wanted people to consume really at every meal. These include curcumin, green tea, rosmarinic acid and rosemary, a host of different herbs like thyme and sage and so forth. Many fruits that we consume, many vegetables that we consume have these polyphenols that are epigenetically active and seem to help direct DNA methylation towards a biologically younger profile. And I just want to stop there and see if you have any questions for me.
Oh, I have a million questions for you, actually.
Okay, good.
So, well, first, actually, before we get further, can you just explain, for anyone listening, what exactly is DNA methylation?
Yeah, so going back again to looking at gene expression. So DNA methylation is one of the best studied epigenetic processes. So epigenetic is defined as above the gene, epigenetic, above the gene. And so epigenetics is concerned with those biochemical interactions with our DNA that either turn on a DNA, a given gene and allow it to be expressed, or inhibit it and shut it off. I know I listened to actually a really interesting podcast that you recorded, and in your introduction, you say something really compelling and important this is not verbatim, but you talk about basically genes not being our destiny. So what we can do if we haven't been handed, sort of the gift of perfect genetics. And the fact is, none of us have. And the more science is unpacked, the more we realize it's epigenetics. It's this interface, not with our DNA and our environment. It's what influences DNA, and whether it's turned on or not is where the rubber meets the road. And here we have a lot to say. Now, DNA methylation, what we studied and what many scientists are concerning themselves with, is really the most well-studied and has the sort of the best platform for testing out of any of the other epigenetic marks. So there are many ways that gene expression is influenced. There are many epigenetic pathways that are happening, if you will. But DNA methylation is just arguably one of the most important and really one of the best research. We know, for instance, that DNA methylation dictates the fate of stem cells. We know that DNA methylation and demethylation, so putting methylation groups on or taking them off, is a major part of embryogenesis, gametogenesis, and on, dictating whether that pluripotent cell in that, in that developing fetus is going to become a brain cell or a heart cell, et cetera, et cetera. So DNA methylation and demethylation plays massively important roles throughout our lifespan. With two X chromosomes, it's DNA methylation that shuts one of them off in every cell. DNA methylation is retained through cell division. So there's a heritability of DNA methylation marks. But again, it's a continuum. So we absolutely know that our diet and lifestyle have great influence on those DNA methylation patterns. And again, I just want to stop and see if you have any questions.
Yeah. Well, no, I mean, it makes perfect sense. So basically, we have our genes, and it's what we do with our life, what we eat, what we think, even, what we do physically, right? That's going to turn our genes on or off. So we might be more susceptible to something, but I believe there's like some saying the genes load the gun, but your diet and lifestyle pull the trigger, basically. So makes total sense. Now, you mentioned cruciferous vegetables as being really important. And so cruciferous vegetables, those include things like broccoli and cauliflower, those sulfur-bearing ones, usually the ones that have that smell.
Distinct,
very distinct, that bite to them. So why are that class of vegetables, why are they so beneficial?
Yeah, well, there's a handful of these polyphenols, sulforaphane sort of being a classic one, diindole methane being another one, but there's more than just those two. There are many. So these polyphenols are, they exist outside of the mineral and vitamin and sort of protein content. Sometimes they're actually interestingly referred to as the dark matter of nutrition, because there's such a high level of complexity and there are so many of them that we're still kind of characterizing them. So cruciferous in particular, but many other nutrients are packed with these polyphenol compounds that seem to direct how DNA methylation happens. It's wildly interesting. And I'll give you an example. And if I forget, I just want to say we're releasing a book in January 2022 called younger you, and it's the study program, I created an extensive appendix. It's the first of its kind appendix with these epinutrients. So I go into detail on these polyphenols and where you can get them. It's actually a massive, really, it's a labor of love. Like I'm so proud of that appendix. So if people get into this and are inspired about it and want to pack, every bite of food that they put in their mouth with these important compounds, this appendix would certainly help facilitate that. So they seem to be able to dictate how DNA methylation happens. And I want to give you an example from where from where most of the science is. As we age, there are genes called tumor suppressor genes. Tumor suppressor genes, as the name implies, keep us cancer free. These are all important genes that do all sorts of extremely important activities in the body, from regulating estrogen production and how it's produced, say, in a hormone sensitive cancer, like, the BRCA protein that Angelina Jolie made famous when she had her mastectomy and her hysterectomy, because she has that mutation. The BRCA protein is a classic tumor suppressor gene that's mutated in a handful of cancers, such as hers, and there's a family history of cancer. But it's a classic tumor suppressor gene. There are many, many, many other tumor suppressor genes that really just take care of us in so many ways, keeping us cancer free. As we age, these tumor suppressor genes get hypermethylated. That's what we refer to when DNA methylation kind of lays down these inhibitory compounds onto the gene, and the gene is not able to be turned on. So tumor suppressor genes are inhibited as we age. Tumor suppressor genes are also inhibited in cancer. In fact, cancer in the tumor microenvironment in a cancer, it will hijack epigenetics and turn off genes that will shut it down and turn on genes that will allow it to be promoted. There's an interesting body of research, a lot of it happening in cells and in animals, less in humans, because this is a new field, and we're actually looking at this right now, show that these beautiful, all-important polyphenol compounds allow for the re-expression of these genes when they're hypermethylated and turned off. So when you think about curcumin in turmeric, or when you think about EGCG in green tea, these are classic nutrients that we've been consuming for time immemorial. There's already clinical research showing their potent anti-cancer activity. Probably a chunk of that is because they're redirecting epigenetics. They're redirecting DNA methylation. They're allowing these genes that were turned off to get turned back on. I want to tell you one other really interesting thing here. So yes, we want to be bathing ourselves in each of ourselves in this food information. In every bite, we want to be directing DNA methylation traffic as much as we can. But there are lifestyle activities that do the same thing. In fact, there was a study published really not too long ago, and I do talk about it in the book because I kind of packed it with there's so many studies just busting out at the seams in this field that up until the last minute, I was writing about new ones. This shows exercise behaving like these polyphenols. I mean, it's so cool. So exercise, inhibits methylation of these tumor suppressor genes, or allows these protective tumor suppressor genes to get turned back on. We know exercise is good and protective against cancer. We know that exercise is good even when you have cancer, as something that inhibits recurrence of cancer. And this is probably the key mechanism, that it's allowing these tumor suppressor genes to get turned back on. So exercise is acting like a polyphenol. Isn't that amazing? I mean, it's just so cool to me.
Yeah.
Like exercise is your physical, corollary to the cauliflower you've got in your lunch today. And let me tell you one other really neat thing about this. As we age, as I told you before, these genes get turned off as part of the aging journey, as scary as and unfortunate as that is. Exercise in an older population actually yielded more bang for the buck. Like it it allowed more tumor suppressor genes to get turned on than in a younger population. So there's no time like the present. It doesn't matter how old you are to be adopting these habits for a biologically younger profile, but also a healthier profile.
I'm glad that you mentioned that because I do think sometimes people feel like, oh, I didn't do this in my 20s or even my 30s, and now it's too late for me.
Yeah.
These changes are not going to make a difference, and it's not
Yeah.
true actually. And
No.
and what you're saying is that it's actually even more beneficial.
Yes,
So that's
that's
very
exactly
interesting.
right. Yeah, it is not true. It is so empowering. We want to have the longest, most healthful life that we can. One of the crazy things that I wrote about in the book was that on average in the United States, we spend our final 16 years infirm, sick, with multiple diagnoses on multiple medications. And just think about that. So maybe our lifespan has increased, in this country, over X number of years, but we're propped up on drugs. Maybe we're in a skilled nursing facility. So yeah, our lifespan might be a little bit longer, but the quality of our life is not. It's tragically poor. So just think about that in the ripple effect. You're not present. You're not able to live a good life as you're getting older. All of your savings, like all of your hard-earned money, I think about this as a mom of a toddler, is going to go towards that care that you don't even get to sort of value because you're not healthy, or your mind's not all there, or you're on so many drugs and the collection of side effects is just absolutely untenable. And so I think we just, need to be screaming from the rooftops that focusing on biological age and health span has to be where we're putting our energy and attention urgently.
Yeah. So we want to eat our veggies, definitely emphasize those cruciferous veggies, maybe even have a serving or two every day. We want to exercise regularly. What are some
Mm-hmm.
of the other lifestyle factors? Like, where does even things like relationships or community
Mm-hmm.
mindset, like where does that come in?
Yeah, that's an awesome question. I want to talk about the pieces of the study, so we'll circle back to what we did, but I want to speak about relationships and community. It's the one piece that we didn't formally research in our study. So our study included diet. We actually gave an additional greens powder. So we gave a polyphenol concentrate, we gave a probiotic, and I can talk about why for that. We tracked sleep and we encouraged good sleep hygiene. We wanted to see a minimum of 7 hours. And again, when we're not sleeping well, that's a pro-aging event. When we're sleeping well, that's anti-aging. And there's a lot of science behind that, including biological age and epigenetics/DNA methylation. We tracked exercise as well. And we had a meditation practice. So we had our participants engage in twice daily meditation. Again, there's a ton of good research and we can circle back to that. But just to answer your question on community, on closeness, it's extremely important. And we're working on how we can look at it in this next level intervention, next study that we're doing. But we see this especially in kids, but in infants, but you see it throughout the lifespan, that contact, cuddling, community, interconnection, all of these C's can keep us biologically younger. In infants, in orphanages, or infants who are mistreated, or just simply have a lack of intimacy, of care provider cuddling, are less developed, have lower IQs. And again, this is mediated via DNA methylation, via epigenetics. Extraordinarily, though, we can intervene. So they can be loved on and cared for even at a slightly older age, and we can see restoration of some of that poor original trajectory. This was shown in animal studies, and this has also been shown in human studies. It influences also our health throughout throughout our lifespan, and it can actually influence health of offspring, from that original individual. Our stress response, our stress resilience can be influenced by that early life attention or lack of attention, how well we respond to, the slings and arrows of life. And just again, I want to underscore that these patterns that we can develop deep in DNA methylation, deep into our epigenome, while we are heartened that we can change them favorably, can also have some resiliency if there's not intentional effort to change them. And that pattern can influence our health later in life, and again, even be, transferred on to future generations. And I want to also underscore too that this is a emerging area of science, and much, much, much more work is left to be done, but it's really exciting.
Yeah, so let's talk about the gut health then, because you mentioned probiotics and that being part of the routine during the study. So can you speak a little bit more to that? Why is our gut health so important, and how did you choose the probiotic? Was it a very specific probiotic with specific strains? Like, what were you trying to accomplish with that?
Yeah, okay. Simply, we chose Lactobacillus plantarum, a specific strain of Lactobacillus plantarum, because there's some evidence out there that it will help increase production of folate. And we want to be bathed in methyl donors, and we want to be bathed in natural sources of methyl donors. We actually stayed away from using supplements, and that's a conversation that we can get into. We just wanted a whole foods matrix, or we want gut-derived methyl donors. And in fact, we did successfully increase circulating methylfolate in our study population significantly. So it was a combination of everything. We can't, just point to the probiotics influence, because we were doing a methyl donor rich diet with our greens and so forth. But we did increase circulating methylfolate, which was what we wanted to do. So that was pretty cool to see that we did. So yeah, a healthy gut microbiome makes a lot of the nutrients that we need, and especially a lot of the all-important B vitamins, which play a huge role in DNA methylation. A healthy microbiome acts on those all-important polyphenols that I was just talking about, and changes them structurally to make them bioactive, so they can go on and do their job on DNA methylation. They help with absorption. So they act on our food in really important ways and help us get in the body, and then once it's in the body, go about and do its work. Of course, we also know a lot about the gut and the inflammation. It's 70% of our immune system is housed around the gastrointestinal tract. If we have an unhealthy microbiome, or if we're exposing our microbiome to poor quality food, we're going to stoke all sorts of inflammation, or AKA, as people are saying now, inflammation, because this inflammation can really drive the aging process, including biological age and including changes to DNA methylation. So for many reasons, keeping our gut impeccably healthy has an important role in DNA methylation and in slowing biological age. There's just a couple of thoughts.
And so in the study, you changed a lot of things for the people that were in the group, right? You had them do intermittent fasting, you had them change their diet, you had them exercise, sleep, all of these things. So for someone who wants to reduce their aging, but maybe doesn't want to go all gung-ho right off the bat, what are the top 2 or 3 habits they can do? Or is there like one specific food they should be adding in? What are like 2, 3 things they can start with? Yeah.
Sure. I would say move as much as you can commit to. You don't need to run out and sign up for CrossFit, but if you can walk around and do that consistently, start with some movement. It's incredibly important, and do the best you can. I talk about this a lot in the book because it is a habit that feels out of reach for people. In fact, I talk about a patient of mine who built a community around exercising just to get herself motivated. And she did something specifically. There's an app out there called Couch to 5K. So for those couch potatoes out there, there's tools. And I put some attention on that, but do the best you can with that. Nutrients. So I would say if you can get some greens in your life, you're doing really pretty fabulous. If you can have a cup of green tea, awesome. If you can find, do you like curry? Can you get a little curcumin there? Do it. If you're open to it at all, get Younger You when it comes out, because surely you'll find foods that you like in this nutrient appendix that are what we call epinutrients, and that you can begin to incorporate right away. Our study participants did follow a specific program to reverse biological age by over 3 years. So if you want those results, get in there and do it. It's 8 weeks long. You can get a lot of support in it if you go through the 3YY program. But start where you can. Maybe get enough sleep if you can. Go to bed a little bit earlier. Room darkening shades. Just little things. Maybe lessening your screen time a smidge before bed. I mean, there's a lot of ways we can do it. We have what we call an everyday Younger You program that I included in the book, and that's a program that incorporates a lot of the awesome structure of what we used in our study, but it's a little bit easier, and it's for those folks who just want to stick their toe in the pond and make some of the changes, and for whom the study diet might feel a bit overwhelming. But there's all sorts of ways we can enter into this conversation of improving health span, lowering biological age. There's just a lot that we can do, and I don't want to intimidate anyone with this journey.
No, that's the thing, right? All these small little steps lead to big results over time. So sure, you can jump in and do all 20 changes or whatever it is, or you can start with 1 or 2, master that, and then you move on to the next one. So you can go at your own pace, and even the smaller things will lead to big results over time. So what was the most surprising finding that came out of this study? Was there anything that you were not expecting?
Well, I anticipated we would shift DNA methylation favorably. I expected that just based on my read on the literature. My colleagues, since our study published, have suggested that we should have done it longer, but it's a relatively intense program to commit to. And if you want people to adhere, which we obviously did, we can't prescribe this for 12 weeks or whatever. I guess what I would say is that the thinking with epigeneticists and those who they're referred to as biogerontologists. So those who are studying in the field of longevity, have thought that it takes longer time to reverse biological age. And when you look at the other studies out there, all of them are longer than ours. But none of them are multifactorial with the diet and lifestyle intervention in the same way that we did. So I think my colleagues were skeptical and have since really, with our our findings, kind of blown away. And I would say that while I anticipated seeing good DNA methylation changes, I did not expect in 8 weeks' time that we would be able to reverse biological age by over 3 years. I mean, that's just massive. It's a big change that, there's nothing out there to date that's been published to come close to that yet. There are studies looking at sort of standard healthy eating patterns like the Mediterranean diet that have shown some small tweaks towards slowed biological aging, but they're much the studies took place over a much longer period of time. I think the secret sauce with our program is that we designed our diet to specifically speak to DNA methylation. So it's not just sort of a generally understood healthy eating pattern, avoid fast food and eat more veggies. It's a very specifically designed with nutrients that we know are epigenetically active. Plus the lifestyle components that we know are epigenetically active as well. And we put it all together. We gave our participants access to the nutrition team that we have here in our clinic to make sure that they knew how to implement the program and that they weren't alone on it. We wanted them to be able to be successful in this. And I think that that was an important piece of our study findings as well. We didn't just hand them a sheet of paper and say, go and do this. I don't know that we would have had significant findings just by doing that. I mean, the book that I'm about to publish it goes into pretty intense detail on how to do it if you want to, and not just what we did in our study, but if you want to do a more entry or starter version, how you do that. But I spend quite a bit of time kind of holding people's hands through the journey, and that's what we did in our study as well. And I think that was a piece of our findings being this successful. I want to also say one thing about meditation. So something that blew my mind as I was researching the background for our study is how profoundly stress pushes aging forward. We know this, right? We speak to this all the time, but on the biological age clock that we used in our study, a full 25%, a quarter of this clock is influenced by the stress response. My interpretation or my read on the literature is that sort of unmitigated stress is like gasoline on the fire of age. Like it just pushes aging forward, I don't know, as potently as anything. It may be up there with smoking. I mean, I really want to underscore what a big deal it is. I'm a type A person. I've been juggling many things in my work, from seeing patients to teaching at the Institute for Functional Medicine to doing science. I'm raising a toddler. I've got a lot on my plate. And this research really stopped me and it just prompted me to put addressing my stress in a meaningful way, not simply lip service, at the top of my list. And conversely, when we look at folks who meditate, when we look at folks who have a Tai Chi practice, who engage in yoga, people who are trained in these things have lower biological age. But what's as exciting is you can see favorable changes from meditation, number one. So again, to your point, just start, a little bit, and don't say because you're not a guru up high on the mountaintop that, it doesn't apply to you, because it does apply to you, and that you are absolutely capable of making those changes. So that was a significant finding. We will publish later on outcome around tumor suppressor genes and sort of turning them back on. I mean, we've got more research to dive into and publish on. Actually, we're diving into it right now, but I'll have to write about it. And I'm just so excited about just the possibility of what we've created here, of how, our genes aren't our destiny, that there is so much that we can do, and we can measure it and see it change, not only for ourselves and for our own health span and lifespan, but for our offspring, for generations to come. I mean, I talk again to keep harping back to the book, but there are studies out there looking at generations of people. The Dutch hunger winter is a classic one. Overcalyx is another classic one for people who want to Google it and look it up, or you can read about it in this book. You will see that what we're doing today can influence, for generations out. We haven't even fully answered that. And one other piece I want to talk to, this is a little bit tangential to your question, I apologize, is this idea of biologically embedded, our psychology or what we're thinking. You had brought that up at the very beginning, like what we think can influence it. And I would say that that's true. What we experience. So most of this research is in trauma. But we can see life trauma, we can see PTSD in folks who've experienced war or the immigrant experience. We can see it in children and in abuse that happens in all sorts of contexts. That experience can be translated into the biochemistry of DNA methylation and influence genetic expression, and that can be handed down or not. So experience into biochemical changes that dictate what genes are on or what genes are off, and this can be, related to like turning off feel-good hormones like oxytocin or hormones associated, or genes associated with heart disease or brain health, et cetera, et cetera. So yes, our life experience absolutely influences genetic expression, and that science is coming out more and more.
So I'm curious with the trauma stuff, how is that best dealt with? I don't know if you've dove into that or there's any research on that, because let's say, for example, you do come from a family where, I don't know, your grandparents or parents did go through some crazy, significant trauma, and that's kind of embedded in you.
Yes.
Is it just the food and the meditation and the sleep and all of that stuff, or is there anything specifically to kind of get that trauma out of the body that you've found beneficial?
That's great. So it's an emerging area. So the topic of resilience. What does a resilient DNA methylation pattern look like? This is being worked on as we speak. A lot of the science thus far is, here's the trauma experience in DNA methylation, and not just like the Holocaust, for example, has been studied quite a bit, and you can see these varying patterns. You can actually, though, see there is some attention towards the resilience pattern in those extraordinary survivors of the Holocaust who perhaps didn't have the same kind of trauma embedded. And there's a lot of energy being put on teasing these out, but it is new. I have a podcast also called New Frontiers in Functional Medicine. And one of the study authors, Dr. Moshe Seth, who's just a world recognized epigeneticist at McGill University. And he was a huge supporter of ours in study design and so forth, has looked at this in humans and in animal models, really arguably longer than anyone. He's really kind of put it on the map. And people can listen to the podcast. It's a really interesting conversation. His belief, and actually a recent publication of from his group, shows that you can reverse this trauma pattern. And they looked at it in an animal model, and they used, in this particular publication, they used SAMe, so that's a methyl donor, and retinoic acid, vitamin A. And they showed reversal of a specific trauma pattern in an animal model, which, is just amazing. 2 very simple nutrients. Now that has to be translated to humans, but it's heartening. And one of the things that he suggested on my podcast was that there'll come a time when we'll be able to identify these patterns early and make changes, maybe even in utero. So a stressful pregnancy or a mom coming with a stressful history, we can see if the offspring are vulnerable and actually get in there and start to change things early on. So there isn't decades spent on the therapy couch, that we can get in there and influence epigenetic expression towards a resilient, biologically younger, healthful pattern. I mean, the possibilities are big. And I mean, it's just an exciting time to be in medicine. In the interim, what do we do? Well, I would say our program is certainly a piece of that puzzle. But let me talk beyond our program. I don't, obviously we have a lot more research to do in our program, but there was an interesting study published recently, maybe in the last couple of months, showing in bipolar disorder that people who were appropriately medicated so that they had their symptoms under control in a way that worked, were biologically younger than people who were not tended to. So people who were perhaps not doing well as far as their mental health were, aging faster. And so that's an interesting study. I know a lot of folks who are interested in integrative medicine don't want to go the medication route, but it just suggests the stress, just the profound stress of mental illness, of untreated, unaddressed mental illness.
Yeah, there's so much we know, but there's so much left that we also have to learn as well. So a lot of
exciting time. Yeah. And I think that again sort of leans back to how do we do this healthfully? How do we do it using time-honored approaches that we know are safe, et cetera? And we can start there and then build on that.
Yes. Well, thank you so much. This has been really insightful and encouraging. I think everyone listening is probably going to want to implement at least one or two of these things that you mentioned to start reversing that biological age. So if you want to learn more from Dr. Kara Fitzgerald, you can go to her website. It's just her name, drkarafitzgerald.com. She's also on social. So I'll put all those links in the show notes below. And the book is called Younger You. And when will it be out?
Yep. It drops along with the full launch of our digital program 3YY, January 18, 2022. And Younger You program, if you want to just learn about the book and the digital program, is just youngeryouprogram.com. But do hop over to our website and you'll just, see lots of stuff from our clinic to the podcast and, all of that jazz.
Wonderful. Well, thank you so much.
Thank you.
Thanks for listening to The Glow Life. If you have questions, comments, or topic ideas, head over to Instagram @Maria Marlowe and drop me a line. If you enjoy the show and think others might too, please share this episode and take just 1 minute to leave a review on iTunes, Amazon Music, Spotify, or whatever platform you listen on. Your review truly helps the podcast grow, reach more people, and bring on incredible guests. As a thank you, send a screenshot of the review to info@mariamarlowe.com and you'll get a free copy of Glow From Within, a 3-day reset plan to nourish your body, calm your mind, and ignite your soul. It comes with a delicious 3-day meal plan to help you bring out your inner glow. P.S. You can listen to the podcast on iTunes, Amazon Music, Audible, Spotify, and even watch the video interviews on YouTube.